Good afternoon, everyone. I am so lucky that I'm the last speaker of the day, because I'm what stands between you and a cold beer. So I understand the importance of getting through this in a relatively short period of time. So I will start with the presentation. 2017 is going to see the energy efficiency of the code increase by about 15%. You're going to be seeing that type of an increase every code cycle. So every 5 years, you're going to be seeing this kind of an increase. The National Model Code has gone from nominal R values to effective R values. Effective R values take into account the heat loss through the structure of the building, right? Ontario in 2017 isn't going to effective R values, but they will be calling for continuous insulation on the outside of buildings, which is their way of introducing effective R values. And then by the next code cycle, we in Ontario will be at effective R values as well. The rest of the country is headed there. Alberta, BC, Nova Scotia, those that adopt the National Energy Code, they are the ones that are going effective R values. So Ontario's following suit, but we're not calling it effective R values, we're calling it the use of continuous insulation on the exterior of the walls. Air barriers are going to become really critical now. They are in the code now, and they will continue to be inspected. And the inspection on air barriers are going to become very, very stringent. Right? So I'm going to be spending some time talking to you about air barriers and the building science behind all of this as well, because you're going to need to understand it. You're going to need to understand the principles of building science, because you can't build stuff the way you used to build it when we've got codes jumping by 15% every 5 years in terms of energy efficiency. So you've got to stay with it. You've got to learn the do's and don'ts, and building science, the elements of heat flow, moisture flow, and airflow. You need to understand that and what drives it all. And I'll tell you, air leakage is a killer in everything. And because of that, air barriers are moving to the outside. Right now, air barriers are inside, and it's the poly that's being used as air barriers. As homes get tighter, and as your renovation projects are going to get tighter, it's going to be more difficult to seal the poly as the air barrier. So you've got the industry looking at moving that air barrier to the outside, right, and using things like exterior insulated sheathings. Reason for that is the codes are going to be calling for it anyway. Whether you like it or not, you're going to be using an exterior insulated sheathing. Right? If you can seal that insulated sheathing as your air barrier, you've just addressed the 3 principles of building science, and you're managing your construction risk as well. And we'll get into that a little. Having said all of that, you are now looking at your renovation projects or your homes as a system. You can't make a home super tight and super insulated. You can't or make the envelope super tight and super insulated without addressing things like mechanicals. We have Energy Star builders in Ontario today who are getting comfort complaints because the homes are coming in at 2.5 air changers or lower, but yet when we do the calculations for mechanicals under the current F280 standard, it's calling for 80,000 BTUs. And under the current standard, it assumes a house leaks. It assumes the air changes in a house are 8 air changes per hour. 8 air changes per hour. So when you put an 80,000 BTU furnace in a home that's 2.5 air changes or less, what happens? The furnace starts short cycling, and you're getting rooms that are cold in the winter and hot in the summer. So you need to take this into account when you're doing some renovation projects or building. By 2030, the government wants the whole industry building to net zero standards. And we're involved in a program with Enercan because of some of the things you're going to see here that got their attention. We're involved in a 5-year program with builders that we will be building affordable net zero homes right across the country. And I'll tell you, I think, based on what I've seen from these builders, we will be there before 2030. All right? This is just the way things are going. And the business opportunities that you have because the codes are jumping like this in terms of energy efficiency, thermal upgrades. If you're not talking about that to your customers, whether it's whether you've landed a kitchen renter or a bathroom renter, or you're doing a rec room, you should be working all of this into your conversations with the home buyers and even offering some suggestions in terms of how it's going to reduce their energy costs and how it's going to reduce their bills. Things like thermal upgrades, air sealing. How many of you have an air sealing package when you go in and do any kind of renovation at a home? Yeah. Every one of you should have an air sealing package, right? Air tightness alone, and you'll see the numbers. Air tightness is critical. You cannot super insulate the envelope of a home, because if it leaks like a sieve, you're throwing money out the window. You're wasting your time insulating. So the two go hand in hand. You got to build super tight, and you've got to insulate it properly as well. And the other thing that has nothing to do with energy efficiency is acoustics. But what's driving that is the fact that homes are now becoming more tighter, right? So all the noise that used to come in from outside isn't getting in. So what's becoming prominent in the house is all the household noise. So we have renovation contractors and we have builders who are offering acoustical upgrade packages as well. So there's an opportunity for you in those 4 categories to put a package together for your builders. Here's what's happening with the codes. This is the 2017, this is what the 2017 code is going to look like. This is already in the 2012 building code as an addendum, right? So you're going to have ceilings and attics going to an R60. You're going to have grade or walls above grade going to an R22. It'll range from an R22 to an R26.5. In the current SB12, there's 12 packages you can choose from, right? In the new SB12, come 2017, there will only be 5. And out of those 5, 3 of them will be calling for continuous insulation. So there'll be 1 package with an R19 and an R7.5 insulation on the outside of the structure. There'll be 2 packages in the code for an R19 plus R5 on the outside. And then there will be a package where you can use an R22 bat, and you can use an R24 bat, right? And depending on the efficiencies of the mechanicals and air tightness and that type of thing. We sell an R24 bat. And I would not recommend you using an R24 bat without using some kind of exterior insulated sheathing on the outside, right? And I'll show you why in terms of what it could cost. When we're looking at basement walls, take a look what's going to happen with basements. It's going to be R20 to R28. It's going to range in that range from an R20 to an R28. The furnaces are going to go from a high of a 94 efficiency. They're going to go to a 96, so there's going to be a range from 90 to 96. HRVs are going to be mandated in the 2017 code. Can't build them tight without ventilating them right. So HRVs are going to be in the code as a standard by 2017, right? And then hot water heaters or domestic hot water, the efficiencies are going to be 0.67, a range of 0.67 to 0.8. When it comes to thermal performance of additions to existing buildings, this is what's going to happen. The ceilings are going to go to an R60 plus high heel truss. That's what they're going to be asking for in the code. Ceilings for attics with or without air, so cathedral ceilings or exposed floors are going to stay the same at an R31, but above grade walls, you will not have a choice. There will be R19 bats, or R20, which is 6-inch in a 5.5-inch cavity is an R19, plus an R5 continuous insulated sheathing on the outside. So whether you like it or not, by 2017, you're going to be using an exterior insulated sheathing. Right? That's the way the codes are going. Basement walls, R20 plus an R8 continuous insulation. And the reason for that is moisture, and we'll talk about that. I'll talk about that a little later. A heated slab and the edge of the slab stays the same. That's not changing. It's going to be an R28. Windows are going to a 1.6, and skylights stay the same at 2.8. So that's what's happening with the codes. These codes are going to be ramping up every 5 years in terms of energy efficiency, and what's going to be driving it are programs like this. Right? Energy Star was at an EnerGuide 80. Right? The codes have now caught up to Energy Star, to an EnerGuide 80. Now, that doesn't mean that if a builder builds to an EnerGuide 80, that it's an Energy Star home, because Energy Star is EnerGuide 80 plus, plus, plus. Okay? But the codes are at EnerGuide 80. Energy Star has just jumped to an EnerGuide 83, which is 25% better than the code. Our R2000 program is at 86, which is 50% better than the code, right? And that's the stepping stone that's going to be used to get to net zero. So every 5 years, you're going to see, in 5 years' time, the code going to an EnerGuide 83. You're going to see Energy Star jump by another 25%. You're going to see the R2000 jump by another 50% until we get to net zero. That's the stepping stones or the steps to success in terms of net zero housing. So that's what's going to be driving the codes. By the way, Energy Star, I don't know if I said this already, but Energy Star has been the most successful energy efficiency program in the history of residential construction. So people are willing to pay for it, as long as you know how to sell it, right? What's going to happen is in 2014 is going to be, Enercan's going to be introducing a new rating system. Now this is going to be your best friend. Whether you're a renovator or whether you're a custom builder, this is going to point out the difference between you and the truck and ladder guys that sell price only, okay? Because remember I said the house is a systems approach. You got to look at it that way. That's exactly what this EnerGuide rating system is going to do. It's going to talk about the attic insulation. It's going to talk about the wall systems. It's going to talk about the foundation. It's going to talk about air changes, right? Where the house comes in terms of air changes. All that is meant to educate the homeowner on energy efficiency, right? And the importance of air tightness. On the other column, all of this is going to be talking about the mechanicals and how energy efficient the mechanicals are. There'll be a 1-800 number on the back of this where homeowners can call, all right, to get more information on this. You've heard probably a couple of days ago, and we don't have the information yet in terms of how the government is going to do this, but Ontario introduced a long-term energy plan, and it's all focused on conservation. Right? So there will be incenting homeowners to increase the energy efficiency of existing homes. Right? So you guys got to get up to speed on this because this is going to impact your business big time. If you handle it right, this will be absolutely fantastic for your business. Okay? I don't have the details. The government just announced it a couple of days, so we don't know how they're going to structure it, but they are hell-bent for leather, excuse the language, to drive energy efficiency. They don't want to build any more power plants. And their view is that the energy that you save is cheaper than the energy you produce. Right? So it's going to be heading in this direction. This is going to become your best sales tool when it comes to renovations. How many of you have blower doors? Do you know what a blower door is? Yeah. Well, I tell you, you should probably make that part of your package. It's probably a $4,000 cost. Not that I'm here to sell blower doors. But what a package that would provide when this comes out. You can do the actual blower door test for the homeowner. While you have that set fan, you can walk the homeowner through the house and you can literally pick out all the leakage areas in the house. That is a huge eye-opener for homeowners, big time. You can talk to them till they're blue in the face, but they don't understand it until they see it. I'll tell you, that $4,000 investment will just add big time to your bottom line. So you should consider doing it. Now, having said that, you just don't get a blower door test and set it up and try and run it. You got to get trained, and you got to get certified that you know how to use the equipment, right? But I tell you, it's something that you guys should be taking a look at really, really seriously when it comes to that, okay? The building science behind all of this, and the reason why the federal government has gone, the National Building Code has gone to effective R values is this. If you take a look at the wall on the left, on your left, it's an R19 wall, 2x6 with an R19 bat in the cavity. Okay? So the R value through the cavity, the nominal R value is an R19. But take a look at the effective R value. It drops to an R15.7. So from an R19 to an R15.7 because of the heat loss through the studs. Okay? Take a look at the wall on the other side. Similar R value, it's a 19.5, right? But when you take into account the added insulation on the outside of that wall, the actual effective R value is an R18. So that's 13% lower heat loss through this wall system than the 2x6 with an R20 bat in it. All right? The most popular wall system by 2017 will be an R20 bat with 1-inch foam. So an R19 with 1-inch foam on the outside. That will probably become the most popular and the most cost-effective wall system. Okay? So that's thermal bridging. That's what effective R value takes into account, is the loss of the heat through the bridging, through the structure. The other thing you need to understand is what happens in the cavity with moisture when you put more insulation into the cavity. And I'll tell you, I love to sell insulation. That's what we do. But take a look at this. This is an R19 bat in this cavity. Okay? Indoor temperature is plus 20, outdoor temperature minus 20. Okay? Take a look at the inside temperature of that OSB. Minus 18.5. And that's with just an R19 bat in there. That temperature will drop to close to 20 if you put an R24 bat in that cavity. Okay? That's why I'm recommending don't put an R24 bat in the cavity unless you're using 1-inch foam on the outside. Okay? Now, take a look at the same wall, but with an inch of foam on it. Same temperature inside and out, but look at where the temperature is of the inside of that sheathing. It's minus 11. Significant increase in the warmth of that cavity. The more foam you put on the outside of the wall, the warmer that cavity increases. Right? Now, there's also some scare, or there's people out there who think, well, yeah, but if we put exterior insulated sheathing on the outside, we're going to create a double vapor barrier. Well, that's not the case, because if you take a look at this, it's not vapor diffusion that's the issue. Right? Vapor diffusion is moist vapor in a gaseous state that goes through a solid material, and then it'll condense on the first cold surface it hits. So the first cold surface it hits is the back of the sheathing, right? And that's where it condenses into water. As long as it's in its gaseous state, doesn't matter how much moisture or how much vapor gets into that wall. As long as it doesn't condense, you don't have an issue, right? But as soon as it turns to water, it kills. Air leakage destroys a home, big time, right? The wall on the right without poly, the wall on the left without poly, you're going to get all kinds of moisture forming inside that wall to the point where that wall will not dry out, right? Because there's no poly on the inside. The only way you stop that is if you make that foam thick enough on the outside so that it warms up the cavity so the dew point is on the outside of the foam, right? And within 10 years, you watch, within 10 years, if I was a betting man, this industry will be at 2 inches of foam on the outside as a standard. And poly will probably be history because you won't need it. Okay? You take a look at where poly is now with 1 inch of foam on the outside, that poly stops 94% of that vapor pressure from trying to get into the wall. Right? So it's the poly that's stopping it. Right? Whatever gets into the wall is so minimal that if it does condense, right, it'll dry itself out. Okay? So the importance of putting exterior insulated sheathing on the wall, it doesn't mean you're going to have a double vapor barrier. It doesn't mean that at all. All right? And the only way to get rid of vapor barriers is to increase the thickness of foam on the outside. And the magic number for Canada is 2 inches of foam. 2 inches of foam, no matter where you are in Canada, 2 inches of foam, you don't need poly on the walls. Right? So we will eventually get rid of poly altogether. In the code, this inboard-outboard ratio takes into account everything I just told you. Right? That calculates whether or not you're going to have trouble with moisture in the cavity if you're using exterior insulated sheathing. Right? So it measures the outboard temperature, what the R value is outboard of that inside temperature of the insulation, to the total R value of the wall inside of that. Right? So you take one over the other, divide it, and you come up with a ratio. In our climate area, we're in this heating degree day zone. So we're up to 4,999 degree days. That means that you need to stay above 0.20. You need to stay above that ratio. Right? So 20% of the insulation, in other words, has to be on the outside of the wall. Okay? So that you don't have any issues with moisture in the wall. A 2x6 stud, 1 inch foam R19 bat comes in at 0.29. Right? So you can use that. In this example, this wall system came in at 0.44, and this is right out of the code, by the way. Came in at 0.44, so that means you can use it all the way down to heating degree days of up to 7,999. It's the effectiveness of exterior insulated sheathing. All right, so it's all covered in the code, so you don't have to worry. As long as you stay above this thing, above the ratio for your heating degree day area, and ours is 4,999, you don't have to do that. And you don't have to do the calculations because the manufacturers will do this for you. Or you just look it up in the code, and it'll tell you what areas you need and what thickness of foam you need on the outside to prevent condensation. Okay? The other thing is air leakage. Air leakage is absolutely critical, guys. And this is why it's going to be moving from inside to outside. When you seal with poly, when you seal with poly, this is what happens. Okay? And this is just on the outside of the home. All right? So you got to make sure that it goes around everything on the envelope of the home, and that equates to about 24 junctions that you have to be concerned about. That's not counting the penetrations in the poly from plumbing, from electrical outlets, plumbing pipes and all that kind of stuff coming through the poly that have to be sealed properly. Right? We have people running around, depending on the size of builder you are and depending on the size of the renovation contractor you are, when air barriers are being inspected, we have builders who have crews just running around with tape and caulking, or tape and foam, just to make sure that what has been done will pass the inspection of air barriers. That's how stringent the air barrier testing is and is going to be. So there's 24 junctions just on the outside, not counting the interior stuff that you have to look at. If you count that, you're probably adding another 10 to 15. Okay? When you do this from the outside, you got 8 junctions to worry about. Everything can be seen from the outside. Right? That's why builders are now looking at exterior insulated sheathings and how they can be used as air barriers as well. Right? Because you address the 3 principles of building science. And what I'm going to show you now is, and I'm spending a lot of time on airflow and air leakage, because I'll tell you guys, if we don't get this under control, if you can't get a home tight, then everything else just falls apart. You're going to get moisture into that cavity, and it's not going to dry out. And it's just going to cause all kinds of issues in the industry. So there's 3 airflow mechanisms. One is wind, stack, and mechanical. When the wind blows against the house, right, it causes a positive pressure. The other side of the house then is at negative pressure. Remember about building science, everything has to be equal. It's an equilibrium, right? So whatever gets into the house has to get out of the house, right? So what's happening is you're getting all the polluted air coming in, and you're losing all that conditioned air that you spent money on, okay? The stack effect is when cold air comes to through the bottom of the home, gets warmed up, it rises, and then escapes through the top, right? And then the mechanical effect is if the home is super tight and not properly ventilated, you get backdrafts. So the furnace kicks in, and then it's sucking all that CO2 back into the house because it doesn't have enough combustion air if the house is too tight and not ventilated right. In our climate zone, the killer to all of this is the stack effect. Air leakage accounts for 30 to 40% of the heat loss in the home. And during the summer, by the way, that stack effect accounts for 20% of the heat loss, or 20% of the air conditioning loss in a home during the summer months. So it's important to make sure that you're offering, right, a sealing package to your customers when you're going in and doing renovations. Even if you're not doing anything on the exterior, you should be talking to your homeowners about sealing and air tightness and the rest of it.